Hello friends, welcome back. This is our third video on analog electronics. So till now we have studied diode basics, forward biasing, reverse biasing and diode characteristics. In this we learn how to find out R on and R off. Now we are proceeding to open circuit test. So why OC test? When two or more diodes are given in a circuit, like if this is a circuit, how to find state of the diodes, whether this is on or off, whether this is on or off. For this we will proceed to the open circuit test. So the OC test is whenever a diode is given in a circuit, open circuit the diode first. Suppose this is a diode. First open circuit this diode. This is connected to some circuit, let us say. So what we will do is open circuit this diode. So what it will look like? Like this. Now find out the cathode and anode potential. This is the anode, this is the cathode, or simply P and N. You are familiar with these notations, right? So I am taking this as P, I am taking this as N. After open circuiting the diode, check the P voltage, check the N voltage and calculate Vp minus Vn. If Vpn is greater than threshold voltage, then diode will be in on condition. If Vpn is less than threshold voltage, diode will be in off condition. So this is the procedure. Whenever a diode is given, just open circuit that, find out the P voltage, N voltage and find Vp minus Vn. If Vpn is greater than V threshold, diode is on. If Vpn is less than V threshold, diode is off. So this is very simple, guys. I will tell you with examples. See here friends, there are three circuits given. We need to find out the diode state now. So what is the first step we will do? We will open circuit the diode. So this is 0.7 volt, this is 1.3K. After open circuiting the diode, we will find Vp minus Vn. What is Vp here? 0.7 volt. What is Vn here? 0 volt. Because there is no current flowing through it, voltage across Vn is 0. So what is Vp minus Vn? That is 0.7 volt. What are our conditions? If Vp minus Vn greater than V threshold, then diode will be on. For silicon diode, V threshold is 0.7. So here Vp minus Vn is equal to 0.7, not greater than or less than. So what will be our diode condition? I will tell you. For an instant, assume silicon diode to be in forward bias. So what it will be? If silicon is in forward biased, it is the equivalent circuit across silicon diode. This is the direction of current and the voltage should oppose the current. So this will be equivalent circuit. Neglect the internal resistance. So 1.3K. Now what is the current flowing through the circuit? I 0.7 minus 0.7 by 1.3K. That is 0 ampere. It indicates that the diode is open circuited. So I can conclude that whenever Vp minus Vn is equal to threshold voltage, in this condition also diode is open circuited. For diode to be forward biased, Vp minus Vn should be strictly greater than V gamma, not equal to, strictly greater than V threshold voltage. So here I am changing the conditions, guys. Vpn greater than V gamma, it is in on condition. When Vpn less than V gamma and equal to V gamma. In this both conditions, diode will be in off region. So this is one problem. Next, observe the next problem. Here a circuit is given. It is germanium diode. So what is the first step? Open circuit the diode. It is 0.7 volt. It is 1.3K, and find out the Vp minus Vn. Vp is 0.7, Vn is 0, Vpn is 0.7 volt. Threshold voltage of germanium is 0.3 volt. I told you this in the first lecture. So since Vpn is greater than V threshold, diode will be in on condition. So if the diode is on, what is the equivalent circuit here? It will be like this. I told you how it is coming in the first lecture. So this is 0.3 volt. Now what is the current flowing through the circuit? 0.7 minus 0.3 by 1.3K. Since in this condition Vpn is strictly greater than V gamma, Vpn is 0.7, our V gamma is only 0.3. Next, if you see this circuit, open circuit the diode. Vp is 1 volt, Vn is 0 volt. So Vpn is totally 1. But silicon diode threshold voltage is 0.7 volt. So here Vpn is greater than threshold voltage. Diode will be in on condition. So turn on the diode. What is the equivalent circuit? Like this. It is 0.7 volt. What is the current flowing through the diode? I equal to 1 minus 0.7 by 1.3K. Friends, if I ask you to find out the RAC and RDC, that is on resistance, which I explained in the previous video. So I am not doing that now. I hope you know how to find it. So just find it. What is the formula for R on? R on, it is having two, RDC and RAC. RDC is V by I, RAC is nu Vt by Id. So if you don't understand this guys, go to my second video and watch that. Now here there is only one diode, so it is in on condition or off condition. What if in a circuit there are more than one diode? Like there is a diode here, there is a diode here. So how to find the states of the diode in this condition? Let's move forward. So case 2, when more than two diodes are present in a circuit. When more than one diode is present in a circuit. See, the solution is diode which is having more Vi minus Vc will become on first. See, if you look at this circuit, he given this circuit and he is asking us to find the I1 current through this diode. So what is the first step? Open circuit all the diodes. It is 1K. It is 1K. What is the next step? Find out the VAC across each diode. See, this is anode, this is cathode. This is anode, this is cathode. So I am finding VAC across this diode first. Since this is an open circuit, what will be the voltage here? 6 volt. What is the voltage here? 0. I am numbering this as 1, this 2. So VAC1 is 6 volt. Next, I am finding across this, friends. Here it is 6 volt. Here it is minus 6 volt. So VAC2 is 6 minus of minus 6, that is 12 volt. See, across diode 1 VAC is 6 volt. It is greater than V threshold, and across diode 2 VAC is greater than VAC is 12 volts. That is also greater than V threshold. So diode 1 VAC voltage is greater than V threshold, and diode 2 VAC voltage is also greater than V threshold. So in these cases you should not turn on these both diodes, guys. What you should do is diode which is having more threshold voltage, you should turn on that diode first and should check the conditions of other diode. See here, I am turning on the second diode first because it is having more VAC voltage. So let me turn on that. What will be equivalent circuit look like? 1K, 1K. Assume they are ideal diodes. So it is the equivalent circuit. Friends, why I am turning on this diode? Because it has more VAC voltage. That's why I am turning on this diode. Next, after this step, you should check the voltage across diode 1 another time. This is anode, this is cathode. So what is VA? Let me find the current through the circuit here first. I equal to 12 by 2K. That is 6 milliampere. So VA will be 6 minus 1K into 6 milliampere. That is 0 volt. So VA is 0. VC is also 0. So VAC will be 0. Since it is an ideal diode, 0 is equal to threshold voltage. So what I said, whenever it is equal to threshold voltage or less than threshold voltage, diode will be in off condition. So first diode will remain in off position. This is the total circuit. So whenever you see this circuit, guys, generally what mistake the people do is, they will check the VAC1, they will check the VAC2, and they will think that both are greater than V threshold. So we can turn on both the diodes. So what they will write is like this. And from this circuit they will find the current through this diode. And they will write the answer which is strong. 50% of the people will do this mistake. So I will provide you complete information, guys, about every point in detail. So this is the procedure to solve the problem. I am explaining you another time because this is very important. First, open circuit the two diodes. Check VAC across diode 1 and VAC across diode 2. Turn on the diode which have more VAC. So here VAC2 have 12 volt, VAC1 is only 6 volt. Both are able to turn on because both are greater than threshold. But what is the procedure? We should turn on the diode which has more VAC. So I am turning on this diode. After turning on this diode, we should find the VAC across first diode again. So again if we find out VAC, VAC1 is 0. Since it is 0, diode 1 will be in off position. So what is the I1? 0 ampere. This is the answer. And there is another special case in this diode, guys, I will tell you. Guys, if you observe this circuit, I am having two diodes here. He is asking the current through silicon I1 and current through germanium diode I2. So what is the first step? I should open circuit the two diodes. So this is 2 volt. This is 1 kilo ohm. Next, what is the next step? I should find VAC across diode 1 and VAC across diode 2. So VAC across silicon, that is 2 volt. VAC across germanium, this is also 2 volt. See guys, if we see the case 1, there is only one diode. So if VAC is greater than V threshold, we turn on that diode, that is okay. If we see case 2, there are 2-3 diodes and diode which is having more VAC, we will turn that on first. But in this case 3, silicon diode is having same VAC and germanium diode is also having same VAC. So what should we do? Thing is, diode which is having lower threshold voltage should turn on first in this condition. So if you observe, the threshold voltage for silicon is 0.7 volt. The threshold voltage for germanium is 0.3 volt. So germanium diode will turn on first. So I am turning on the germanium diode now. This is silicon diode. This is germanium diode. So if we turn on germanium diode, what is the equivalent circuit? It will be like this. So it is the 2 volt, it is 0.3 volt, it is 1 kilo ohm. Next, find out the VAC across silicon diode again. So what will be VAC here? It is nothing but 0.3 volt because these two are in parallel. So VAC across silicon is 0.3 volt. which is less than V threshold. Why? V threshold of silicon is 0.7 volt. Because VAC across silicon is less than V threshold, it will be in off position. So what is the answer, guys? I1 equal to 0, I2 equal to 2 minus 0.3 by 1 kilo. That is 1.7 milliampere. This is very important question, guys, in IAS exam and some PSU exam and state exams. With very important question. See what you should do when VAC is equal to VAC-GA, you should check the threshold voltage, and diode which is having lower threshold voltage, you should turn that on first and check VAC across another diode. So is this okay, guys? So this is the summary, friends. In case of single diode, when VAC greater than V threshold, then the diode will be in non-state. There is no confusion at all. When there is one diode, open circuit that diode and find out the VAC across that. If VAC is greater than V threshold, then diode will be in on state. When more than one diode is present, diode having more VAC will turn on first. So when 2 or 3 diodes are present, open circuit all the diodes and find out VAC across all the diodes. So diode which is having more VAC will turn on first. After this, what you should do? Calculate VAC across other diodes. And the last case, when there are 2 or more diodes present and the diodes are having the same VAC, then which will turn on first? That is, diode having less threshold voltage will turn on first. Example, there is silicon and germanium. Germanium will turn on first. After this, check the condition for silicon diode. So first germanium will turn on. So if you got this concept, guys, hit like and subscribe to my channel. With this, the concept regarding diode is completely over, and from the next video, I will solve the get previous year problems regarding the diode circuits. So guys, do subscribe to my channel. It really boosts me to make next video. Only subscribe if you are learning something from this channel, and hit like button if you are enjoying this. So in the next video, we will solve the previous year gate problem. Thank you.